Hi, so I'm going to talk to you today about some fun I had putting together my own home alarm system controlled by Node. I'm Michael Dawson, I work for IBM, and if you noticed, our other presenter was also named Mike, but I can assure you that you don't have to be named Michael to work on Node at IBM. So just a little bit about what it is. What I wanted to have was an alarm system for my cottage. You can see in the picture it's fairly modest, but we like it, and there's good TV reception. So I wanted to have an alarm for when we weren't there so that I'd know if anything was going wrong. So why not just buy one that you could get off the shelf? Well, I like things where I can make them do what I want them to do, not what somebody else would want it to do. And if something goes wrong, I also know how to fix it, so it's great. It's open source. You can go in, pull it down from GitHub, and if you want to participate, I'd be very helpful, very appreciative of that. There's lots of things that could still be done to improve it, so if anybody has any interest, that's where you can go and get to it. The hardware you need to put it together is fairly modest. It's a Raspberry Pi, some 433 megahertz receivers and transmitters to connect up the Pi so you can talk to the external devices. And then there's a whole bunch of 433 megahertz sensors and actuators that you can get through eBay to actually make up your alarm system. It also uses USB cameras, so when the alarm's triggered, it'll start to take pictures of the intruder stealing your stuff. And I also have an IR illuminator so that if it's dark, you can still take pictures. So a little bit about the different technology pieces that I use to put it together before I show you the overall architecture. It uses several execution environments, so it uses the Raspberry Pi as the actual physical device to interface with the RF frequencies in the cottage itself. And then I use Docker. I have 3 different Docker instances to run the pieces that all connects together and where the main Node engine runs. It's written in Node, of course, which is the main backbone, but I also use C++ in the Raspberry Pi itself. That's where you actually interface with the GPIO lines and all that. And of course, Bash scripting to just link things together because the Raspberry Pi gives you a Linux environment. There's also a bunch of protocols. Mqtt is one of the really key ones. It's the message queue telemetry transport. It's a very simple publish and subscribe type system meant for device-to-device communication. And it makes a really good bridge between the physical world and the Node applications that are running. Of course, we want to be able to provide a nice GUI without having to refresh to get updates. So we use WebSockets to provide real-time updates. I wanted to have notifications wherever I was, so it uses SMS to send messages to your phone when something goes off. And of course, to make sure that somebody else can't get into your overall alarm system, you want it to be secure, so it uses TLS and SSL along with certificates to make sure that everything's encrypted. And only the components that you expect can do that. And then things like HTTP to present pictures, and SCP to transport those pictures from the physical location to where I host the actual pictures. There's a couple of Raspberry Pi specific components that are quite useful. FS Webcam, which lets you interface with a USB webcam very easily, and Wiring Pi, which is a nice library that lets you actually work with the pins, handle interrupts, and so forth much more easily than if you tried to do it yourself. So looking at the overall solution, in your home, you end up with Raspberry Pi, and it's got the wireless module, so it can talk to these other components, like the motion detectors, the door sensors. Even you can get wireless fire alarms, so when the fire goes off, it'll send a signal and you can pick that up. And then I also built my own infrared illuminator, which I can turn on and off over the wireless so that you can take pictures in the dark. To support those, there's a number of processes running in the Pi. There's the 433TX, which is basically a process that says, I'm going to take messages on the MQTT on some particular topics, and when I get those, I'm going to publish out the messages over the wireless. And the 433RX is just the reverse, where it's going to say, okay, when I receive a message, I'm going to publish that to a topic. And that's where MQTT comes in as a really nice bridge between the physical world and the higher level where we're actually running our Node applications. So, and the third one is the Pi Webcam, where it does the same kind of thing for the webcam. It's, again, an MQTT interface that lets you say, please take me a picture, or I've taken a picture, here's the name of the picture if you want to display it on the graphical interface. So when the alarm goes off, you'll end up having the sensors will give you a message will come in over the RF frequencies. The Pi recognizes that, decodes it, publishes it to a particular topic over the MQTT server, which happens to be running out in the cloud. So all of my Docker containers are running in the cloud. If you're not familiar with what Docker is, it's basically an easy way to get very lightweight Linux instances. So I have a Linux Docker image for an MQTT server, which everybody else connects into to be able to publish and receive their messages. There's a second one for an HTTP server. So if for the pictures that you want to be able to view, they're transferred over SCP to that server, and then obviously through HTTP you can get them from the browser. And then finally, the main piece is a Docker container running a simple Node application that acts as both the back end and provides a nice GUI to your phone or your desktop. And they all communicate through the MQTT server. So when the alarm goes off, you know, the RF frequency comes in, the Raspberry Pi picks that up, and it just publishes a message to the MQTT server, and after that it just forgets about it. So really the Raspberry Pi doesn't know what's going on. It's just your bridge to the physical world. The Node application says, oh, okay, I got a message. It told me that zone 1 went off. Therefore, is my alarm turned on? Yes. Okay, I'm going to signal an alarm. At which point it says, well, okay, I want to actually send out notifications. And I've used Twilio, which is a service out on the web that lets you actually send SMS messages. It can actually let you do a lot of other things too, like send, call up a certain number, play a recorded message. But it's a nice way to interact through the telephony system to send SMS messages to your phone. So in my case, it just says, by the way, your alarm just went off and you might want to do something. The Docker, the Node application in the Docker instance also provides the GUI, so you can hit it with your browser, and that's where it uses WebSockets to be able to provide online and real-time updates as to what's going on, and you basically get a little alarm console, which I'll show you in a few pages. So, if somebody breaks in and steals your Raspberry Pi, because maybe that's the most interesting thing that you have, all of your data and the alarm state's out in the cloud, so it's safe. Everything's still going on there. All you have to worry about is your internet connection, but if you lose that, you're not going to have any luck anyway. So the first thing I was going to delve into a little bit more detail is just Node and MQTT. As I mentioned, you put those together, and it's just awesome sauce. It's really a good fit. The asynchronous nature that Node gives us and the sort of publish and subscribe model that MQTT provides, they just fit together like a glove, and you get something where something happens in the physical world, and now you get an event in Node, and you can take the right action. And similarly, if you want to make something happen in the physical world, you just publish a message, and it happens for you. So on the receive side, it's just as simple as saying, we create our MQTT connection, and then we register some callbacks that on our connect that say, well, I'm going to subscribe to a number of different topics. So I have like a topics like the alarm status topic that will tell me the alarm was armed, disarmed. There's a zone, a new picture topic, which says, hey, a new picture was just taken. So if I'm displaying my pictures, I can say, here's the new one and where to get it from. And then there's a zone mapping where for each of the zones in your alarm, it says, well, okay, if I get a message on a particular topic, that means something happened in this particular zone. And so, you can see the code is really quite simple to do that. On the send side, it's just as simple to make something happen in the real world, where basically you just have to say publish take on the camera picture topic, and now the process in the Raspberry Pi is going to say, okay, yep, I'll take your picture for you and send back the information that you need to get that later on. Delving a little bit more into the details of interacting with the physical world, the Raspberry Pi doesn't come with the FM or the RF components, but it's very simple to put them together. You can see the circuits here, which I didn't come up with these myself, but I drew these nice pictures. You need very few components, and in a couple hours you can solder yourself together a little daughter board that you can plug in, and now you have your Raspberry Pi. The little thing on the left is a temperature sensor if you want to do some other data about what's going on as well. The other nice thing is, and why I use those frequencies, is there's just actually that frequency is used by a bunch of existing alarm systems, and you can just go out and buy these components. There's like the standard protocols there. It's 2272 and 2262. Simple, I think they're like a remote control protocol, and they're like 24 bits. You can basically program each of these devices to have a particular address with a certain number of data bits, and so when the motion detector goes off, or the door is opened, or the fire alarm goes off, you get a very simple message that says, it's like FFF10. It's a tri-state protocol. The mapping here basically says, I'm going to have, in this case, 5 zones. I actually, since I could program these myself, I programmed them to have, numbers 1 through 5. And then the second line is the zones that says, okay, how do I want them to show up in the GUI in terms of how they're displayed as zones? And then the names that you've given them. So you can really easily add in new zones, new types of devices, and that's half the fun, is getting the devices in. The project is up there, the main project is up there, but all the dependent projects that actually decode the signals and all there are there as well. So if you want to add your own devices, that should be pretty straightforward too. So this is an example of, okay, the alarm goes off, you want to take a picture. So in this case, it calls IR on that says, hey, I want to turn on the IR light so that I'm going to be able to see in the dark. That's a little interesting in itself in two things. One, it's not that easy actually to get webcams that will give you the IR feature, but you can actually take a lot of the cheap ones and just remove the IR filter, and it works. Although it was a little easier, it sounded easier reading the things on the web. It sounded easier than it was. I had to go through about 3 or 4 different ones from eBay to find one that, it's supposed to be easy, but then you get it and they've changed the way they built it, even though it looks the same. And eventually, the local dollar store had these ones where you could just pop it off at the back. It was really good. The other thing, too, was this is a case where it's nice when you're building your own thing, because nobody actually had a 433 megahertz IR-controlled system, so I basically built my own. Just built a little circuit. There's chips which will decode the protocol, and the same receiver that went in the Pi, so I now have something that will turn that on and off just like the other devices you could buy. And up at the node level, you can see it's very easy. It just says, okay, I'm going to publish a topic, publish camera IR on the camera IR topic. That ends up sending the message to the Raspberry Pi. It picks it up, sends out the right signal on the RF, and the light goes on. And similarly, you send the message to the Pi to say, okay, well, I want the USB camera to take the picture. So you just publish takes the picture, and then it publishes back to you, oh, I've taken your picture, and here's the name of it, and here's the name where you can find it on the HTTP server that I uploaded it to. So looking a little bit at the GUI that you ended up getting, the one thing I'll point out is that, if you've ever watched Doctor Who, somewhat like the TARDIS, it's a little bit bigger on the inside than the outside of the cottage. And probably messier than my wife would have liked than if I was showing a picture in an audience, but you end up with an alarm console. You can basically disarm and arm it from anywhere. So if the internet was working here, I could connect in and turn it on and off. You can request a picture. So if you want to take a look and see what's going on, even if there's nothing going on, you can do that. It shows the latest 4 pictures that have been taken. You also maybe want to be able to see what's going on, so you can hit the show log and get the picture that you see on the right, where it tells you, this is what's happened to your alarm. Different zones have been triggered. I've armed and disarmed it. And then if you want to actually see the pictures, you can click on the pictures, and it pops up a window. You can actually have multiple cameras. So if you want to have multiple different camera views, I had 2, one which was like a regular camera and one was the IR camera. You can select between the different views at the bottom and cycle between them. And of course, because it's web-based, I can also see that on my phone, which is nice. And that's one thing I haven't done that would be nice, is I haven't made an actual native app that would run on the phone. That would be a nice addition to make it a little bit slicker on that side. The other thing I mentioned is you can actually get SMS messages. So again, that's on the Node side. That's really easy to do. Twilio lets you get a phone number for free, basically. They're generally limited to like beta numbers or something like that. But even if you needed to pay, it's like $1 a month and a cent to text message or something. But I have a free phone number, and it's really as simple as this. There is a little bit of additional stuff to like read in your account IDs, but it's 15 lines of code, and you've basically sent yourself an SMS message, which is another really nice way to interact with the physical world when you're nowhere even close to what's going on there. If you wanted to put, so because I've deployed all the components in the web, where's one place you could do that for free? Well, on our IBM Bluemix PaaS, you could deploy the Node app, and it even supports container services, so you could deploy Docker images there as well. So if you want to get your own system up and going and want to do it for free, that's a good option. And I was going to do a demo if time permits, but I still couldn't get the web up and going. So